This is Emanuel Goldman, a professor in the Department of Microbiology, Biochemistry, and Molecular Genetics at Rutgers, New Jersey Medical School, and I am presenting a poster entitled Higher Concentrations of Bacterial Enveloped Virus Phi6 Can Protect the Virus from Environmental Decay. My co-authors are Ronald Bangiyev, Maxim Chudaev, and Donald Schaffner. Ron, a graduate student in the master's program at Rutgers School of Graduate Studies, did most of the laboratory experiments with the assistance of Maxim, a research associate in my lab, and myself. Don, a professor in the Department of Food Sciences at Rutgers, New Brunswick, contributed to the analysis and interpretation of our results. Early in the pandemic, there was a great worry about the virus spreading by fomites, that is, inanimate surfaces and objects. People were disinfecting their mail, their groceries, and everything else in the mistaken belief that this was the way to prevent transmission of the virus. In July 2020, I published online a comment in Lancet Infectious Diseases challenging this presumption. The title of the comment was Exaggerated Risk of Transmission of COVID-19 by Fomites. The crux of the argument was that the concentrations of virus used was way too high in experiments showing long survival of the virus on surfaces. Since the virus decays with a defined half-life, the more you start with, the more half-lives you have to go through before reaching an endpoint of less than one infectious virus particle on the surface. In other words, the experiments that were the basis for concern about fomite transmission of COVID-19 were unrelated to real-world conditions. It turns out to be even worse than I originally thought. The experiments in this poster, now in press, in Applied and Environmental Microbiology, show that an envelope virus, bacteriophage Phi6, protects itself from environmental decay at higher virus concentrations. Phi6 has been suggested for use as a non-pathogenic surrogate for SARS-CoV-2, the causative agent of COVID-19, which is also an envelope virus. Therefore, the design flaw in experiments measuring surface survival of SARS-CoV-2 is not just that too much inoculum requires more half-lives to go through. The larger inoculums extend the half-lives as well. The Lancet comment was picked up by the press. A columnist from The Atlantic coined the term hygiene theater in an interview about the Lancet comment. Other research corroborated the assertions in the Lancet comment. And finally, Nature, the journal Nature, posted an editorial citing the Lancet comment, calling on public health agencies to emphasize aerosols and stop warning about fomites. Nevertheless, publications continue to appear promoting fomite transmission as a risk, hence the need for the kind of work presented in this poster. The effect of higher concentrations protecting the virus is dramatic. For example, in Table 1, when 12,000 virus particles were dried on a plastic surface, 15 minutes later, 10,000 virus particles were recovered, or 83%. But if 1,200 virus particles were dried, 15 minutes later, only 27% were recovered. And when the inoculum was 120 virus particles, the recovery was only 13 virus particles, or 11%. Similar patterns of protection by higher virus concentrations were found under multiple experimental conditions. The exception to the rule was when LB growth medium was added to the virus samples, which had a protective effect, delaying decay, regardless of virus concentration. These results have implications for our understanding of transmission of many other respiratory viruses. For almost all respiratory viruses, a route of fomite transmission has been inferred based on the same kinds of surface stability experiments using way too much virus. And I now believe that very few, if any, of the respiratory viruses have a significant component of fomite transmission. Flu, for example, has all but disappeared during the pandemic, clearly a result of the public wearing face masks. The bottom line is that most, if not all, papers asserting fomite transmission of respiratory viruses, including SARS-CoV-2, are likely artifacts due to envelope viruses protecting themselves from decay at high concentrations. These are diseases that you get by breathing, not by touching.